Did you know that over 90% of check engine light repairs are either misdiagnosed, overpriced, or completely unnecessary? That number might sound outrageous, but dig into the data and you'll see just how common it is for drivers to be sold parts or even expensive system replacements without a proper diagnosis. According to a report published by Kelley Blue Book and CarMD, roughly 20% of drivers completely ignore the check engine light, while another 20% delay taking action for several months. That's nearly half of all drivers putting off the most important warning signal on the dashboard. And it gets worse. A study highlighted by Reviews.com and Motor One found that only 36% of drivers actually get their CEL checked within the first week, while almost 30% wait between 1 month to a full year, and 25% never get it checked at all. Just let that sink in for a moment. That behavior has real consequences. And here's where the problem compounds. When most people do finally go in, the majority end up being misled into replacing parts they didn't need. CarMD's 2023 Vehicle Health Index backs this up, revealing that the average check engine light repair costs around $403, with catalytic converter replacements topping the list at over $1,300 on average. But the real kicker? Many of these converter replacements are based on a generic code P0420, which doesn't actually confirm the converter has failed. See, what happens in a lot of these cases is simple. You show up with the light on, the mechanic plugs in a scanner, gets the code, and immediately suggests a part replacement. No further testing, no smoke test, no live data check. Just a part swap and an invoice. And sadly, that's become the norm in many shops. It's not because they're all bad mechanics, it's because they're under pressure to move fast, bill quickly, and keep the next job moving through the door. Most of the time, when that light pops on, your mechanic might just grab the scanner, clear the codes, and point to the most visible part. Replace the oxygen sensor, the catalytic converter, or maybe the MAF sensor. It's a lot like going to a doctor for a headache and having them prescribe brain surgery. The scanner reads a code, P0420 for instance, flags catalyst system below threshold. It doesn't scream, replace the catalytic converter right away. But that's usually the first solution shops jump to, loaded onto the invoice as a complete diagnosis. It's a $1,200 sale, but it might not have been a necessary one. Let's look at this closely. The scan tool gives you a code, great, but no shop actually drives the car to replicate the fault, no smoke test is performed to detect vacuum or exhaust leaks, and there is no thorough live sensor data reading. Once the code surfaces, the usual path is to replace parts until the CEL goes away. And even though that approach might work, it's expensive, uninformed, and often unnecessary. Consider this. Drivers routinely spend over $1,000 swapping a catalytic converter, only to find weeks later that a faulty or dirty downstream oxygen sensor was actually the problem. You can't diagnose a turbo or emission system through guesswork. You need real testing. That's what most shops skip. The data, the smoke test, the functions of circuits, the pre- and post-fault states. Take the P0420 example again. It's the most commonly misdiagnosed code. Mechanics see it, and their next line is, the CAT converter is failing, need replacement. But OBD2 mechanics, automotive bloggers, and independent mechanics point out this. An oxygen sensor could just be giving false readings, the MAF might be pulling faulty data, or an undetected leak could throw off your readings. The car doesn't lie, but the scan tool can. Without validating the data captured by sensors, channels through labor, and parts cost can balloon. Sites like Car Parts stress that P0420 doesn't automatically mean a bad CAT. It could be anything from sensors, worn spark plugs, small leaks, or electrical issues. Yet shops still push converters because it costs them less time and effort to replace than to diagnose. You might find this scenario frustrating because it's not rare. It's the default. I've seen at least a dozen cases in my professional and personal experience where a large job was just a rushed assumption. A catalytic converter failed? No. A vacuum hose cracked? Yes. Faulty O2 sensor? Yes. Cars are expensive to repair, but these misdiagnoses push them off the cliff much sooner than they should. So why does it happen so frequently? Because this model is profitable, simple, and scalable. But it leaves drivers out to dry, literally and figuratively. You put your trust in the repair shop, but leave with a heavy bill and the same light blinking in the rearview mirror 3 months later. But I'm here to tell you, you don't have to let that be your story. You can arm yourself with knowledge and tools that allow you to ask critical questions, make better decisions, and literally save thousands. You may not call yourself a mechanic yet, but with the right guidance, you can act as your own advocate, with confidence and clarity. Here's where we're going. First, I want to walk you through the most common check engine light codes and their usual misdiagnoses. One of the most common is P0420, then the P0171, and next is the P0172, and then P030X, and many more. I'm going to tell you what the real issues look like, and why a full diagnostic approach saves money and headaches. Then we're going to talk about tools. Affordable tools, like a $20 OBD2 scanner, a smoke machine, and a vacuum pump. You'll learn how to test live data, interpret fuel trim values, measure oxygen response, and inspect wiring and connectors. We'll walk through a step-by-step routine to follow when the light illuminates, so you're not walking in blind. And I'll share real-world cases where individuals avoided expensive repair bills once they knew what to look for. Finally, I'll show you how to talk to mechanics. Or better yet, how to give them fewer excuses to upsell parts. When your check engine light flicks on, it doesn't automatically mean something catastrophic broke. It means your car's internal warning system registered something abnormal. Maybe it's a minor glitch, a dirty sensor, or something as simple as a loose gas cap. It might also point to a wiring fault, low fuel pressure, or failing spark plugs. The key is not to overreact, but don't ignore it either. Treat it as a real warning. Get to the root cause with tools and informed thinking. Let's dive into some code and misconceptions. The P0420 diagnostic is a classic example. Diagnostic shops often present it as an uncoupled converter. But in truth, only 30 to 40% of P0420 420 cases result from a truly failed catalyzer. Instead, the other 60-70% come from the upstream oxygen sensor refusing to respond, a small exhaust leak, low-grade fuel causing inefficient burn, or even calamitous wiring and electrical chatter. So when a shop tells you cat replacement is necessary, remind them to test sensors, the wiring, and run smoke through the exhaust system first. Believe it or not, once you do that exhaust pressure test and measure the downstream temperature difference across the converter, you often don't need a replacement. Or let's talk P0171, B0172 codes, system too lean or rich. They often blame oxygen sensors and injectors, but a common cause is simple vacuum leaks, cracked hoses that let unmetered air in. One driver I recall posted a comment about spending half a day chasing injector cleaners, only to discover a collapsed PCV valve hose doing the damage. It's that level of simple. With a can of brake cleaner or a smoke tester, you can find the leak yourself and fix it for $10. Then there are misfire codes, P030X. Many shops jump in to replace coils, spark plugs, or even failing engines to find cylinders misfiring. But the solution? A fuel injector may be clogged, or you may only need to clean your spark plug boot. Or a second compression test may show near-perfect cylinder pressure. With a can of fuel system cleaner and a multimeter test, you can sidestep expensive part swaps. But look, I get it, car repair is emotional. When that little engine light flashes, we tense up. We think something catastrophic happened. We decide to trust mechanics because we don't want to be alone with these unfamiliar parts. And that's why this system keeps working. We pay thousands to escape discomfort. Here's the antidote. When that light turns on, get to your car's OBD2 port. Connect a $20 scanner and record live data, fuel trims, oxygen sensor responses, misfires, and MAF readings. Watch how the car reacts during warm-up and underload. If fuel trims hover around plus 5%, your engine's running well. If you see plus 115%, you're running lean. If 15%, you're rich. These numbers tell a diagnostic story that guides you to the real problem, not just a code. Then run a vacuum check, inspect hoses, listen to the throttle plate open and close, sniff for exhaust leaks, and use smoke testers if you can. Plug in small automotive test equipment and phone apps to record readings as the engine warms up. If codes persist, you've come prepared, not assumed anything was failing. Mechanics aren't infallible. They aren't evil. They're busy and under pressure. They want a job to move along, but you can change the script. When you walk in armed with your check results, your logged data, charted O2 readings, and intake pressure, you shift from being just another customer to the person who knows what's going on. Suddenly, your mechanic isn't selling, You're comparing information to actual symptoms. Let me tell you about a guy named Jonathan. He came to me after a shop quoted one lasting $600 to fix a high-mileage Japanese import with a Puro 302 misfire. They wanted to rebuild the cylinder head. Jonathan hooked up a scanner, watched the drop in RPM live, and found the misfire cleared when he sprayed brake cleaner on his vacuum lines. We found a cracked intake boot that cost $50 to replace. Jonathan walked away, saving $1,550, and a repaired head that didn't need it. Another viewer, Amanda, was told her oxygen sensors and catalytic converter all needed replacement. She went to a reputation-based chain shop and was quoted $2,400. Instead of taking the hit, she came to me. I advised her to ask the shop for a smoke and wiring test. They found a bad ground on the oxygen sensor wiring. $80 later, she reset the light, and the converter and sensors were still performing as specified. She only needed a $75 wiring harness. These are not anomalies. They're all over comment sections, forums, and repair logs. Unfortunately, we don't read them, or we don't assume it applies to us, but it does. Every one of us faces these issues. We deserve better. Now, let's talk about real steps you can take. When that light comes on, count to 10. Don't panic. Before touching anything, attach your cheap scanner and grab a snapshot of live data. Let the car warm up and record those fuel trims under light acceleration. Are they in range? Are you seeping or overshooting? If fuel trims look explained, yet the light stays on, check coolant temp, intake air temp, O2 voltages, MAF volts, throttle footprints. A slight error in voltage, even 0.05 V off, could flag a sensor. Now check vacuum hoses. Run a small smoke test or spray brake cleaner around hoses, listening and watching for changes. Found a leak? Fix it. Wait, retest the scan, and watch fuel trims. No codes yet, drive it and monitor. No light, diagnosis done. If codes persist, that's okay. Now, you're ready for part replacement. But you're replacing because you tested first, not because someone got billed. And that's the difference between being a reactive spender and a proactive solver. Here's the kicker. If you walk in with test results, observations, and recorded scans, mechanics listen. They test what you tested. They become your ally, not your enemy. You're paying for skill, not guesswork. You're saying, this is what I saw. Now let's confirm the external parts, but I've already done the testing. You walk out with more knowledge, fewer surprises, and most importantly, your money stays in your pocket until it's actually warranted. So in the next part of this video, I'm going to show you how to interpret the visual data graphs your scanner spits out, and I'll walk you through a real recalibration drive. We'll go over oxygen waveform shapes, fuel trim envelopes, cold versus hot engine behavior, throttle plate responses, and timing differences. I'll demo a real smoke test on a 2007 mid-size crossover and reveal what a harmless intake leak looks like versus a dead cylinder. You'll be able to tell whether that CEL deserves replacement parts or just a timeout and a calm look at the data. If all this made sense, you're already outpacing 90% of drivers. If you're ready to walk through this process with me, step by step, let's jump into the next video here on the 8 ways WD-40 is ruining your car. I will see you over there.